the day before at like midnight.
I bought a notebook for your class, but I haven't touched it since.
That's cool.
Because I thought we were going to have to write our notes.
Okay, implicit differentiation. First, let's talk about equations that are defined explicitly versus implicitly. Explicitly are when it says y equals something. That's explicit. So, when it's y equals blah, 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 blah. Implicit is like this. When you have x and y together, and y is not all by itself. This would be a pain in the booty to get y by itself. You can, it actually ends up being those two up there. But it's a pain. So instead of saying f prime of x or y prime, we're going to start writing it, at least for these, as dy dx. Now, the reason why there's basically two people that came up with calculus. And so there's a blending of their two ideas. And one of them had one set of notation, and the other one had another set of notation. So this notation, this dy dx, which I don't know if you have any see with that.
Why can't we just write f prime?
Because it's going to help us later on with these types of problems, with implicit.
Why didn't we just start off with the one on the right?
With the dy dx?
We kind of did.
I mean, we
Well,
did,
we-
but...
I mean, we talked about it, we just didn't use it much because it was kind of a pain. I mean, we wouldn't want to do that all the time.
Why didn't we use that when we were doing inverses? That would have been easier than having.
You think it would have been? Ooh, I don't.
Well, it's not like we're gonna have two F's beside each other. We have F with like
Yeah,
apostrophe
well,
and
that's
F in
true.
every one.
that's true. Maybe. That's the way I learned it, so there's...
It's just Miss King.
There you go. Okay, so here's what we're going to do. We're going to start with this one on the left, the y equals 25 minus x squared. And we're going to derive that like we normally would. So normally we would write this as 25 minus x squared to the 1/2.
I was like,
Now, just to get used to the other notation, we're going to say dy dx, which just means a derivative. And then you do 1/2 times 25 minus x squared to the negative 1/2. Then you take the derivative of the 25 minus x squared. Remember the chain rule.
2x.
Negative 2x, yep, times negative 2x. I can simplify this sum. The 2 and the 1/2 will cancel. So you get negative x on the top. And on bottom, we have the square root of 25 minus x squared. Now, do you agree?
Yeah.
Okay. That y equals 25 minus x equals the square root of 25 minus x squared.
Yes.
So I can replace this 25 minus x squared with y if I wanted to. I'm not saying I have to. I'm just saying, hey, it makes it look a little prettier.
Oh, no.
That's
Ooh.
tricky.
It's going to be a lot more work
Will it though?
now. One more step.
No, the reason we did that was so that we could see that this thing is going to be the exact same. These two equations are equivalent. They're both equations of a circle. It's just this one has been solved for y, and this one is not. This one's implicit. The other one's explicit. So let's take the derivative of this implicit equation. Now we're still taking, it's dy dx, so we're taking the derivative with respect to x. So we start with x squared. Derivative of x squared is 2x. And then if I had to take the derivative of the x on the inside, if that was an issue, it would just be 1, right? Plus, derivative of y, you treat it just like you would an x.
2y.
It's 2y, except for we also have to take the derivative of y with respect to x. So that's dy dx. And we did that over here as well.
So it would be 2.
Yeah, here, when we took the derivative of x squared, we got 2x. And then you do take the derivative of x, it's just 1 with respect to x. Here, take the derivative of y squared, which is 2y, and then you take the derivative of y with respect to x. And that's why it's dy dx. It's not just 1 because it's with respect to x. So that's where the dy dx is coming from. Equals, what's the derivative of 25?
0.
0. Yeah, the derivative of a constant is 0. Okay, we want to get dy dx all by itself. So we're going to subtract 2x. Then what? Divide by what? 2y, right?
2y. Wrong order.
So the 2's will cancel,
No.
Yes.
and you get dy dx equals negative x over y. Notice you got the exact same thing.
How?
Because they are the exact same equation. Just one was implicitly defined and the other one was explicitly defined. I thought the implicit one was easier. Plus, I wouldn't want to get y by itself here. I mean, you could, but sometimes you can't. All right. So, yeah, right.
Geometry.
So now we're looking at the circle.
I thought we were done with it.
Never. So we're going to find the equation of the circle. Ooh. Well, we got to find the center. See if y'all can find the center.
I think it's 3 negative 3.
I think it's 3 negative 2.
Yeah,
I can't tell the number.
Well,
It's
you
a
can-
negative 2.
I think it's 3 negative 2.
I can't tell what number it is.
It's not negative 3.
I was about to say, well, just make it bigger.
I
You can do
can't.
that on your paper. Okay, so
I just
yeah,
got a line going.
3 negative 2. Now, in case you forgot, the formula is x minus h squared plus y minus k squared equals r squared. And of course,
Yeah, I
h
forgot
and k is the center,
Yeah, we do.
and r is, of course, the radius.
3.
So it's 3 negative 2, we said?
Yeah.
So that's x minus 3. Ooh, leave a little space. X minus 3 squared plus y plus 2 squared equals, what's the radius?
1, 2, 3,
5 squared, so 25.
Oh, we tried to compare for a circle.
I'm sorry, what?
Was the equation we just did for a circle?
Yes.
The other page.
Yes. It
We're only
is.
going to be dealing with circles now?
No, it's just
Okay.
circles are really nice to show between implicit and explicit. But no, we're not
I don't
only
want
going
to
to
do geometry.
Sorry. So we're going to simplify, well, not really, expand. So this is x squared minus 6x plus 9 plus y squared plus 4y plus 4. x squared plus y squared minus 6x plus 4y plus 13 equals 25. Subtract the 13. Equals 12. Everybody okay? Nobody's crying?
Not yet.
Oh, yes. Okay, so now we're going to implicitly differentiate this equation. Find the derivative.
Okay, cool.
So this is 2x. It's with respect to x, so I don't have to worry about the x
So
mark.
what's the respect doing?
The respect is saying what you're taking the derivative with respect to.
What does that mean?
Like,
You're paying attention to.
yeah, you're paying attention to the x. For this one, yes, we're taking the derivative of it, but then we also have to take the derivative with respect to
So
x.
why do we write it dy over dx? Why
Because
would we not?
it's y looking at x.
Right, because if I just wrote y prime, people would be like, why is it y prime?
If it's 4x.
Yeah, it's 4x.
I just thought of it as like y is looking at x because y is on top of it.
That's fine. Yeah.
We're paying attention.
And see, we're going to be changing variables later. Like, we're going to be doing, like,
Maybe not.
the surface area with respect to time. So that's why it's very important. A lot of things are going to be with
So then it would
respect
be
to time.
ds over dt.
Yes. So a lot of things. So you have to pay attention to what variable you're taking it with respect to, because if it's like with respect to x, then you don't have to put the dy dx here because it's with respect to that variable. But if it's not with respect to that variable, like this y, then I have to multiply it by dy dx.
Because that's what we're solving.
Yes.
It kind of sounds like the things you've been doing, but
Yes.
with different words.
Yes.
Messing with
Because
my
we're
head.
putting these two guys' calculus together. That's what we're doing. Because sometimes it works better using it this way, sometimes it works better using it the other way.
Cool. Okay.
Okay.
Minus 6.
Minus 6. It's with respect to x, so I don't have to worry about it. Now what do I do with the y, the next one?
Plus 4 dy dx.
There you go. Derivative of 4y is 4. But then you also have to take the derivative of y. dy dx.
Oh,
It's like the chain thing.
Yes, it is exactly the chain thing. It's just the difference here is when you take the derivative of x, it's just 1, so I didn't have to worry about it. And I guess we shall stop there. And I will ignore the hallelujah, Faith. Oh, that was funny. Faith, hallelujah, get it? Ah. Hi, Harvey.
Help me have faith.
Oh, gotta have faith, faith, faith. I bet you Harvey